Section 4.1 we'll be doing in 2 halves, and we'll do 2 handouts on each half, and then we'll have a review day and a sample test, and we'll take a test over just this first section in Chapter 4. This section will take us about 1 week to do both parts, the review, the sample test, and the test. So this is going to be a very short section. Be sure you keep up on the notes and homework. Our goal for Section 4.1 is to classify triangles and to find angle measures in the triangles, and this is for the first half. A triangle is a figure formed by 3 segments joining 3 non-collinear points. Remember, non-collinear means not on the same line. So there's a point A, a point B, and a point C, and there's 3 segments or sides joining those. Down at the bottom it says name the sides. These are segments. So I have segment AB, segment BC, and segment AC. Same picture, so if you're drawing the picture, just draw it once. This one says name the angles. There are 3 angles. We have angle A, angle B, and angle C. And if you're asked for an angle, you need to put the angle symbol in front. This slide says name the vertices. The vertices are the points where the segments meet. So we have point A, point B, and point C. Vertices are where the sides or the segments meet. We have Theorem 4.1 is called the triangle sum theorem. This states that the sum of the measures of the angles of a triangle is 180 degrees. And this is talking about the interior angles. Inside of a triangle, those are always going to add up to 180 degrees. We'll also start talking about what's called a corollary. A corollary is a statement that can be proved easily using a theorem or a definition. It follows from that theorem or it follows from that definition. And we'll go ahead and do an example of this. The corollary to that Theorem 4.1, the triangle sum theorem, is called the right triangle sum theorem. This says the sum of the 2 acute angles of a right triangle is 90 degrees. So if I have a right triangle and I know the triangle is 180 degrees, since this is 90 of it, the other 2 also have to add up to 90. This is a corollary because it follows easily from knowing that the 3 angles of a triangle add up to 180 degrees. We're going to use this one picture to do some examples for our triangles, so you can draw this one picture just one time and go from there. So we have this triangle ABC, and they're telling us if the measure of angle A is 70, so angle A is 70, and the measure of angle C is 30, find the measure of angle B. Knowing that our whole triangle adds up to 180, I'm going to add up the 2 angles I'm given, subtract from 180 degrees, and figure out what's left. 70 plus 30 is 100. 180 minus 100 tells me that the measure of angle B is 80 degrees. You can put your degree symbol on or leave it off, but be really consistent just in case it looks like a 0. Next example has the exact same picture. This time we know that the measure of angle B is 20 and the measure of angle C is 110. We need to find the measure of angle A. Again, I'm going to add up the 2 angles I'm given. 20 plus 110 is 130, and subtract from our whole triangle 180 because the interior angles, these 3 angles inside a triangle, always add up to 180 degrees. So 180 minus 130 means the measure of angle A is 50 degrees. We'll also do some of these using algebra. For number 4, the measure of angle A is 3x, the measure of angle B is 7x, and the measure of angle C is 2x. To start, I'm not going to worry about what they're asking me to find. I'm going to think about how I find x. If I add up the 3x, the 7x, and the 2x, if I add the 3 angles in the triangle, I know they should be 180 degrees. So 3x plus 7x plus 2x equals 180. 3 plus 7 is 10 plus 2 more, 12x equals 180. And if we divide by 12, we get that x is 15. Now I'm going to go back to my problem and see what I need to plug in for. They're asking me to find the measure of angle A, which is 3x, so 3 times 15 means that this would be 45 degrees. To double check my answer, I could plug the 15 into the other angles. 7 times 15 is 105. 2 times 15 is 30. 30 and 105 is 135 plus 45 does add up to 180. Just to double check and make sure I got it right. Same picture, and if we need more space, I do have a blank slide we can work this on. This one says that the measure of angle A is 100 degrees. And the measure of angle B is 5 more than twice the measure of angle C. A little trick to word problems. Whatever comes at the end is going to be x. Angle B is being described using this angle C, using x. So it's 5 more than twice x. Okay, twice tells me to multiply by 2. 5 more than that means I'm going to add 5. Again, all 3 angles are going to add up to 180. So I'm going to take 2x plus 5 plus x plus 100 and set it equal to 180. So 2x plus 5, that's our angle B, plus x, angle C, plus 100, angle A, equals 180. Like terms, 2x plus, this is 1x, is 3x. 5 plus 100 is 105, equals 180. We subtract to 105. I know that 3x is 75. And if we divide by 3, x is 25. I'm going to go back to the problem and read what it asked me to find. It asked me to find the angles. I know that x was 25, so C is going to be 25 degrees. I already know A is 100 degrees. B is 2x plus 5, so 2 times 25 plus 5. 2 times 25 is 50, plus 5 is 55. Those do add up to 180, so the measure of angle A, we were told, is 100. The measure of angle B is 55 degrees, and the measure of angle C is 25 degrees. We're also going to talk about different angles in our triangles, and again, this is the first half of this section that we will be testing on. We have exterior angles. An exterior angle of a triangle is an angle adjacent and supplementary to one of the angles in the triangle, made by extending a side. So this side has been extended, and we have this exterior angle 4. It's adjacent to 3. They do make a line, so they're a linear pair. They're supplementary and add up to 180. We could actually extend all 3 sides of our triangles to make an expanded picture, and we'll look at one of those. When we talk about these, we have interior angles that I referred to earlier. Those are the 3 angles inside the triangle. So if we look at our triangle, there's the 3 interior angles. We have what are called remote interior angles. These are the 2 interior angles away from the exterior. So if I extend the side so that I have an exterior angle, remote interiors are these 2. If you think of remote as being like a faraway location, saying someone lives in a remote location, they live kind of out in the middle of nowhere. So remote is far away. So these are my 2 remote interior angles. Whereas an adjacent interior angle is the angle inside the triangle right next to the exterior. So again, if I use this as my exterior angle, this one would be my adjacent interior. Please be sure you write these definitions down. These will be good to read through to prepare for the true-false section of your test. We're going to use the same picture multiple times for examples. We have 4 different examples we'll use this picture for. So if you would draw this once, make sure your angles kind of inside are 2, 4, and 6, and then the 1 is next to the 2, 3 is next to the 4, 5 is next to the 6. This is a picture that has had all 3 sides extended to show 3 exterior angles. If you extend this line to the left, then it's like turning your paper and extending this line left, turn your paper and extend this line left. You shouldn't have 2 exterior angles extending into each other. So this one says name an exterior angle. Exterior angles are these that are outside. So you could use angle 1 or angle 3 or angle 5. Same picture. This one says name an interior angle. Interior angles are the ones that are inside of the triangle. So I could use angle 2, or angle 4, or angle 6. This example, same picture, says using angle 3, so I'm using this exterior angle, name the adjacent interior angle. Adjacent means next to. So an adjacent interior angle would be angle 4. That's the interior angle next to this exterior. And I'll always specify, and I will tell you which exterior angle I want you to look at when doing a problem like this. Same picture, using angle 5, name the remote interior angles. Remote interior are the ones inside the triangle that are far away from this exterior angle. So since 6 is right next to it, the other 2 are remote interiors. So we're going to list angle 2 and angle 4. Remote interiors are the interiors that are far away from our exterior angle. So we're going to look at some pictures and see if we can fill in some missing angles. And again, we'll use this one picture multiple times. So you can draw this once and then list these examples below. So for this picture, draw it once, and then number 1 says the measure of angle 3 is 70. The measure of angle 1 is 60. We're going to find the measure of angle 2 and the measure of angle 4. Again, it's really important to have this picture drawn, and then you can just list the examples below so that as you're working through your handouts, you'll be able to go back and use your notes as a reference. I know if 1 is 60 and 3 is 70, that the inside of my triangle has to add up to 180. So we can do what we did in the examples at the beginning. We're going to add up the 2 angles we know. 70 and 60 is 130. And we're going to subtract from 180. 180 minus 130 tells us angle 2 is 50. We also need to find the measure of angle 4. Angle 4 is not only adjacent to angle 3, the one right next to it, but it's also supplementary to angle 3. So to find angle 4, I'm going to take my 180 degrees that makes a line and subtract 70. Angle 4 would be 110 degrees. Same picture, example 2. Says the measure of angle 4 is 130 degrees. That's our exterior angle. The measure of angle 2 would be a remote interior to that one, is 80 degrees. We need to find the measure of angle 3 and the measure of angle 1. I cannot find angle 1 yet because my interior, based on what I already know, I don't have enough information on my interior angles. However, I know 3 and 4, my exterior and the adjacent interior, are supplementary. Those make a line and add up to 180. So if I do 180 minus 130, I find that the measure of angle 3 is 50. And then we can use our triangle and the fact that it adds up to 180 degrees to find the measure of angle 1. So I'm going to add 80 and 50, and that's 130. 180 minus 130 says the measure of angle 1 is also 50 degrees. Again, you can use your 180 to check. Make sure your straight line, your exterior and adjacent interior are 180, and it's 180 degrees inside your triangle. Theorem 312 states that the measure of an exterior angle, like angle 4, our exterior angle, of a triangle equals the sum of the measures of the 2 remote interior angles. Sum means I'm going to add these 2 remote interior angles. So the measure of angle 4 should be the same as angle 1 and angle 2 added together. Well, let's look back at our previous examples and see if that's true. In number 1, these remote interiors are 60 and 50. 60 plus 50 does add up to 110, which is angle 4. In number 2, we got 80 and 50. 80 and 50 does add up to 130, our exterior angle 4. So anytime I need to find something about an interior exterior, I can use this theorem, that this outside angle, this exterior, is the sum of the 2 remote interiors added together. So we'll have 3 formulas that we'll be using for our triangles. The first one is what we talked about with the interior of a triangle. Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. The second one talks about this linear pair, our exterior and adjacent interior. The measure of angle 3 plus the measure of angle 4 equals 180. And the third one is our new exterior theorem, that if I add the two remote interiors, angle 1 plus angle 2, I get the exterior angle 4. You want to write these in your notes, put a box around them, put stars next to it. These are the three formulas we'll be using throughout this section to find angle measures. Let's see if we can use these to do a couple more examples. Again, we'll be using the same picture for all of our examples. We're going to do 4 with this picture. So you can draw this once, list the examples below it, and we'll kind of stick with where these angles are, but be careful not to just rely on memorizing the numbers. If the measure of angle 1 is 70 and the measure of angle 2 is 50, find the measure of angle 3 and the measure of angle 4. I can use what I know about my triangle being 180 to add up the two angles I'm given. So 70 plus 50 is 120 degrees. The 180 in the triangle minus 120 tells me that angle 3 is 60 degrees. I can use my new exterior theorem to find angle 4. I know that the measure of angle 4 is the sum of my two remote interior angles. So if I take the two angles I'm given and add them together, 70 and 50 is 120. I can double check that because my exterior angle and the adjacent interior should be supplementary. 60 and 120 do add up to 180. So there's lots of ways to find these, but you need to be comfortable with all three formulas in case you're not given enough information to use one that you're currently relying on. Same picture, just list these examples below. Number 2 says the measure of angle 4 is 140, this exterior angle. Angle 1, one of my remote interiors, is 80. We're going to find angle 2 and angle 3. I know that 3 and 4 have to add up to 180. They make a linear pair, so 180 minus 140 means that 3 is 40 degrees. I know my triangle has to add up to 180 degrees, so 80 and 40 is 120. And if I do 180 minus 120, I find that the measure of angle 2 is 60. I can use my exterior theorem to check this. My two remote interiors added together, 80 plus 60, should be the same as my exterior 140. And that works out. So my answers are the measure of angle 3 is 40 degrees and the measure of angle 2 is 60 degrees. Same picture, new example. We're going to add some algebra. The measure of angle 1 is 3x, the measure of angle 2 is 4x, and the measure of angle 4 is 9x minus 24. We're going to find the measure of angle 1, but I want to focus on finding x first. We only have one option. I can only use the parts that I'm given. So using angle 1 and angle 2 and angle 4, I need to look back at those formulas and find the one that uses 1, 2, and 4. If you look back in your notes at the three formulas, the one that uses 1, 2, and 4 was the third one that we talked about. The measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. So I'm going to go back to the problem and apply this. I know that if I add these remote interiors, the measure of angle 1 plus the measure of angle 2, so 3x plus 4x, that should equal the measure of my exterior angle 4, so equals 9x minus 24. 3x and 4x are like terms, so we have 7x equals 9x minus 24. And I'm going to go ahead and leave my minus 24 on the right and move all my x's to the left. This is a positive 9x, so I'm going to subtract 9x. We'll get that negative 2x equals negative 24. And if we divide, x is 12. The problem asks me to find the measure of angle 1, so I'm going to go back and plug this in. 3 times 12 means the measure of angle 1 is 36 degrees. Again, stick with either using the degree symbol or not, just in case it looks like a 0, so I know which one you're using. Last example with this picture, the measure of angle 3 is 4x. The measure of angle 4 is 6x. find the measure of angle 4. Stop first and figure out how you can find x. I only have these two angles. These are two angles that together make a line. They're a linear pair, so they're going to add up to 180. 4x plus 6x equals 180. 4x plus 6x is 10x. And if we divide by 10, we get that x is 18. We're to find the measure of angle 4, so we're going to do 6x, so 6 times 18, which is 108 degrees. The very last example is one that has an expanded picture. All of these angles have been, the sides have been extended so that we can see all three exterior angles. So if the measure of angle 6 is 40 and the measure of angle 2 is 75, we should be able to find all of the angles in the picture. So the measure of angle 6 is 40, angle 2 is 75. Let's see if we can find all of the other angles. I'm going to start inside my triangle and see if I can find angle 4. I know the three inside the triangle add up to 180. So 75 plus 40 is 115. 180 minus 115, if you borrow, gives us 65. So angle 4 is 65. Then I also know that these two, 6 and 5, an exterior angle 5 and its adjacent interior 6 have to add up to 180. So angle 5 is 140. The same thing happens with these two, 1 and 2. So angle 1, 180 minus 75 is 105. And the same thing happens with 3 and 4. So 180 minus 65 is 115. I'm going to use that exterior theorem just to check these. Angle 5 is supposed to be the two remote interiors added together. Remote interiors to angle 5 would be 4 and 2. So if I add these up, I do get 140. Angle 1, the 105, is supposed to be its remote interiors added together. A remote interior to angle 1 would be 4 and 6. 65 and 40 is 105. Angle 3, this exterior, is supposed to be its remote interiors added together. Remote interiors to 3 would be 2 and 6. 75 and 40 is 115. So we found all the angles. We will be doing handouts for this entire section, so when you come back in with your notes finished, we'll be working on handout 4A, 4B, and then we'll take notes for the second half. You do not need to bring your book.